Hey guys, so I have a dual fan here for AC. It's a single phase fan. I cut off one end because I only need one side. I'm trying to figure out how to wire it. Got the wiring diagram right in here. So as you can see, it's a 5-pin fan. I went ahead and cut the pin off. So we got two sides of the circuit. We got the speed side over here, and we got this selector over here. I'm not really sure. I tried it out, and what looks like the orange had a slow speed, and the black had a faster startup. You can connect this side to the hot side and this side to the neutral. You could do it vice versa. I'm not really sure which way is correct, but I believe the hot side should go on the select, and the neutral should go on the speed select. But I can show you that it works either way. As long as this capacitor is parallel with your hot and neutral and your two selecting sides. Okay, so I have my capacitor hooked up with a little light switch. It's off right now. You have to have your hot and neutral plugged in to either side of the capacitor. So I'm going to have my neutral on the 3-wire speed select side, and then the 2-wire other side will be my hot. So I'll plug in orange first to show you that it's slower. It has an extra inductor in the way, which kind of makes sense. And I'm just going to use red for a medium speed. Before you connect anything, make sure you discharge that capacitor. Now I plug this in. You can see the fan a little bit here. Flip the switch and nothing happens because I have that extra inductor in the way. It needs a little kickstart. So I'm going to start spinning this fan a little bit. Then I'll turn it on. It has kind of a slow startup. Now, the fun thing, you want to be careful. If I spin it the wrong way, it'll run just like normal. So it's important to have a start capacitor or spin the fan the right direction when you're starting it. But as you can see, that orange side is pretty slow. So I'm going to discharge that. Now I'm going to plug in the black. And keep in mind that black does not have the inductor in the way, so it should be faster. Now if I turn it on, it goes by itself, and it speeds up quite fast. Now just to show you that it's AC, so it technically doesn't matter which side you have plugged into the hot or neutral because it'll figure itself out. I'm sure there's a proper way to do it, but now I'm switching the hot and neutral. I plug it in and start it again. Should do the same exact thing. I took a little bit more. Since the sine wave is on this side, I'm assuming the orange and black wire has the hot and the speed select is the neutral. Alright, now I'm going to do a speed test. Low, medium, high. I'm guessing blue is going to be low, so I'm going to try blue first. That felt pretty high. Discharge, red. Feels a little lower. And now for yellow, which should be the lowest then. Yeah, that seems about right. Okay. So now I can actually label this because on their silly wiring diagram, thanks LG, it's A1, A2, A3. So A1 is fastest, A2, A3 is slowest. So I saw another video, which I'll link in the description. The guy had this wiring diagram. He was actually using the fan motor as an angle grinder or something, which is pretty fun. Did something similar to me where he cut off half of the fan. So the way he did it is he had the 3 speeds, and he had the hot side connected to the high speed, HML for high, medium, low. And then his neutral side he had connected to the brown wire, which is connected to that capacitor. Okay, so a little more detail. Here's our wiring diagram. This is the goal. We have a fan, we have a capacitor in parallel, and then we have the hot and the neutral. Doesn't matter which way these are, but the hot and the neutral are going to have a fluctuating voltage, and they're going to be a separate phase, so they're going to be going back and forth like this. Now the capacitor ensures that there's always a smooth voltage going towards this fan. So, if all of a sudden the hot dips for a second, the capacitor will be charged and it will supply with that extra voltage. If the neutral dips for a second, the voltage in the capacitor will supply the neutral. So if you also have your compressor connected up here and you kick that on, it's going to have a big voltage draw it's going to have a big current draw for a second, and that's going to cause a big fluctuation in your sine wave. You could think of this as one input to the fan, and this is the other input to the fan, and this is in parallel with this capacitor, and then you have to hook up this capacitor in parallel with hot neutral. I went ahead and I measured the resistance from orange to blue, which is the lowest, and then orange to red and orange to the yellow, it goes up because it has to go through more inductors. Same with black. Starting with blue, it's the lowest and it goes higher, but it's lower. This one's lower than this one because it doesn't have to go through this extra inductor in the middle. So I'm not exactly sure what the purpose is meant for, just like a slower versus faster ramp up. All I know is when I skip this, I don't need to have a startup capacitor because it kind of starts on its own, especially if I'm using medium or high speed. Well, the capacitor I was using before was a run capacitor that had this 35 plus 4 microfarads. If you don't know what that means, the 35 microfarads is for the compressor and the 5 microfarads is for the fan. A run capacitor is different than a start capacitor. The start capacitor provides the initial kick for the fan. This run capacitor just keeps it running. So I only need a run capacitor for this system that I'm designing. So I just have a single 5 microfarad capacitor. Another tidbit of information. If you ever see MFD, that's actually the same thing as microfarad. It's just microfarad abbreviated. I'd also suggest using a 2 or 3 toggle switch. This is just 2. I could select between fan off and then a speed like medium there and then high for that, instead of having to plug and unplug these every single time. So yeah, that's pretty much it. Thanks for watching.